Yeah, hello students. Greetings of the day. Yeah, this is your Ekna sir, faculty in physics from VIP classes. Okay. Yeah, today we are going to talk about horizontal projectile motion. So in the last class we have seen oblique projectile, okay, and numericals and all those things we have seen, isn't it? So you can go through my part one and part two, so of the projectile motion. Okay. So now today we will be talking about now this we got what we can call horizontal projectile. So any object thrown from certain height, isn't it? So when you throw certain object from certain height horizontally, so we can call it as what? Horizontal projectile. Yes or no? So for example, so you have some particular tower or kind of thing, and you're throwing an object horizontally some velocity u. So what happens here? Actually, as you are thrown horizontally, it has to go like this straight, isn't it? But as gravity is acting vertically downward, so because of gravity, what happens? Direction continuously changes, and finally, it lands somewhere else. Okay. So this kind of object which is thrown horizontally can be called as a horizontal projectile. So here already, as we mentioned, it may be here gravitational field. Tomorrow you may throw a charged particle with some velocity in a magnetic field or an electric field. So accordingly we can handle the problem. Okay. So now we talk about here. So motion of an object under gravity. So when you are throwing an object horizontally. So here in the horizontal direction, as we was in case of oblique projectile, in x direction, as there is no effect of gravity. So in x direction, velocity remains what? Constant. But here initially in y direction, if I take this as x and this as y, so initially in y direction, velocity is equal to 0. So you can take downward as your positive. I am taking downward as positive here. Okay. Upward you can take negative. And gravity acting downward, so its acceleration A is equal to plus g. Now after some time, so for example, after some time its position is over here. After some time here, then it lands over here. So at an instant of time, so for example t, so its positions are along x direction x, y direction y. Downward I am taking positive. Okay. So now, so this particular position will be x, and vertical displacement will be here y. Okay, after t seconds. Now as you have seen, in x direction velocity is constant, so displacement in x direction after t seconds, as velocity is constant, velocity is displacement by time, so displacement is velocity into time. So x direction velocity into time. So your x direction velocity, how much you are throwing with u velocity, so u into t. Okay, so from here you can find out the time t will be here x by u. Okay, so you can call this as equation number 1. Now what is its position after some time t in y direction? So in y direction you can talk this one as x direction. Now in y direction, initial velocity in y direction, how much, students? So initial velocity in y direction will be, initial velocity is 0, and acceleration in y direction is 0. So as a result, because of gravity, what is happening? So the horizontal direction is going, but because of gravity is coming vertically downward. So because of acceleration due to gravity. Okay. So now displacement in y direction is some y is equal to, formula is what? Acceleration is constant, so ut plus half a t square. This is in y direction. So in y direction, initial velocity is 0. So you can say 0 into t plus half g into t square. This is what? Y after t seconds. Now our aim is to show that this trajectory equation also a parabola. It is a curve, isn't it? So you can substitute the value of t. Trajectory equation means only in terms of x and y, isn't it? So y will be equal to here now. So half g into t will be x by u whole square. So you can write y is equal to half g x square by u square. So you can mention here g by 2u square into x square. So you can take this g by 2 square as some a. So this implies this equation becomes y is equal to ax square, which is again a curve. Therefore we can call this also a equation of a parabola. See, like the way oblique we have seen, right, in this way. You can consider this half portion. So from here, maximum height. This is what? Half projectile. No, this is what? Horizontal projectile. The part of a parabola, isn't it? So it's also a parabola. Okay, so y is equal to ax square, also equation of a parabola. So therefore the path of the horizontal projectile is also parabola. So any object thrown horizontally from certain height can be called as a horizontal projectile. And we have seen that its trajectory equation y is equal to g by 2u square x square. Okay. Now, so when you are throwing here, certain distance it has traveled in x direction, right? So this distance, how much it has traveled horizontally. Okay, this you can call as range. The time taken to reach from this topmost point to this landing point, okay, is called as time of flight. Okay. So now here you can see how much time it takes. If you see here, later we'll do this problem. Okay. So now the moment it is hitting the ground from here to here like this, in the same moment or same time, it is tracing this vertical height of h, and in y direction just now we have seen velocity is 0. So simply you can say in y direction it is like a freely falling body, isn't it? And so the displacement s is equal to h is equal to ut plus half gt square. U is 0, so half gt square. So t square will be here 2h by g, and t will be how much beta here? That is equal to root 2h by g. So the time taken, okay, to reach the ground is t is equal to root 2h by g. So now here we can talk now. So time taken we know, the trajectory equation we know. So you can also find this maximum horizontal distance in the same amount of time, isn't it? So from here you are throwing with some velocity u, right? So what is happening here? It is reaching x distance here, or this x distance we are calling as range. So range is equal to what? This velocity in the x direction into time of flight. This is u into how much beta? Root 2h by g. So this is the what? Formula for range, and this is the formula for what? Time of flight or time of journey. Okay. And next you can also find velocity after some time seconds, isn't it? So as we are throwing from certain height here, so what is happening here? Particle reaching in this way. So at an instant of time, say for example the particle is somewhere else here. So x direction velocity remains same. Why? Again the reason, gravity is not there, and y direction is accelerating. So velocity after some t seconds is t. Okay. So now x direction velocity is u. Okay. In y direction velocity is u plus at. So velocity in y direction, that is initial 0. This will be equal to gt, and net velocity will be vector sum of these two, isn't it? So this net velocity will be x direction velocity into I cap. So plus what will get? Y velocity into j cap. So v bar will be equal to how much beta? U into I cap plus gt into j cap. If you wish, as I have taken before, y direction positive. Okay. So you can write, if you take positive, positive, or else simply general convention means it is downward. So you can use a minus g, nothing wrong. Okay. So now what is the magnitude of this velocity? Magnitude of this velocity will be under root of u square. These two are perpendicular components, right? So g square t square. So this is the velocity. How much velocity on reaching ground will be here? So same again, this value is u, and vertically downward will be vy is equal to root 2gh. So this will be u. So velocity on reaching ground will be how much? Under root of u square plus root 2gh whole square is 2gh. Okay. So remember these 3 points here. The trajectory equation is parabola, and time taken is root 2h by g, and range is u into root 2h by g, and velocity after any time. And as usual concept, the way we applied for horizontal projection, it remains the same. Okay. Now this is the basic things which you have to remember. Okay. Now we'll talk in terms of the numericals. Now we'll talk here. Okay. The first numerical you can see here. Projectile is fired horizontally with a speed how much beta? 98 meter per second from the top of a hill of 490 meters. Time taken to reach ground. Now what are the formula we derive? Substitute the formula one by one now. Okay. So time taken. So time taken to reach ground. How much time taken to reach ground? Formula is root 2h by g. Right? Root 2 into h value how much? 490 by g value how much? So that is 9.8. Okay. So root 2h by g. So here you can find out now into 10 by 10 if you do know. So this decimal get cancelled. So 49 ones are, 49 twos are, this get cancelled. Under root 100 is how much beta? 10 seconds. Now distance of the target from the hill. Distance of the target from the hill and the velocity with which the projectile hits the ground. Now distance of the target from the hill, if you take from top, answer will be different, and from foot of the tower you can take range. Okay, both the things you can find out. So range from the foot will be velocity into time of flight. So you can note 98 into this 10 seconds becomes 980 meters. Okay, so from this much height, if it is throwing here, right, with this velocity, it will fall here somewhere else, and time taken is here 10 seconds, and this distance we has got as 980 meters. So if you ask the height, or how much height it is, 490 meters. If you ask from the topmost point, so this is the, yeah students, you see here net displacement from topmost point to here point of landing under root of 490 whole square plus 980 whole square. Okay, you can simplify, and that will be the what, displacement from point of projection to landing. Okay, right. Yeah, next you see two buildings are there. Okay, so one is of height of what you can call distance, they are 180 meter apart, students. Okay, and one ball is thrown from the 55 meter above the ground of first building. Another building is what, at a height of 10 meter window is there. Okay, so first one is 55 meter, and second one is how much here, that particular window is 10 meter above the ground. So the gap between them will be how much, 45 meters. Okay, so now you are throwing the object, so from 55 meter above the ground to 10 meter above the ground. Okay, so if you see the diagram here, so the gap between these two, how much beta, 45 meter. Okay, now so when you are throwing it, it's landing on the second building window, right? So that the velocity is how much here, some u value you can say. Now so if you throw with u velocity landing here, the gap is 45 meter, so velocity is here u, so gap is how much here, 55 minus 10 meter will be is equal to 45 meter. Okay, yeah, now you can see, so that window, okay, above 55 meter from the ground, and this window is 10 meter above the ground. So I'm separately drawing diagram, you see it now here. So the gap is here 45 meters. Now simply find out the time taken to land here. So it is like a freely falling body. The gap here I am mentioning as 45 meter, isn't it? So t is equal to, you can mention that value. Okay, so root of how much beta, 2h by z, and the gap between the buildings is 180 meter. That becomes the range. So range formula is what, u into t. So 180 meter is u into t now. Now so for the value of time t, so how do you calculate now? So u into t is root 2h by z. Okay, now that is equal to u into root of 2 into h is how much beta, 45. So divided by g is 10, that is 90 by 10 becomes root 9, that is 3. Therefore 180 is equal to u into 3, and 3 ones are 3 60s are, therefore what you will get, so here u becomes how much, 3 6 are, so u will be equal to 60 meter per second. Okay, yeah, see students, here one more question. A ball rolls off the top of a stairway with a horizontal velocity u. If each step has a height h, students, here see I am drawing the diagram here, and width is b. So the ball will just hit the edge of the nth step. Okay, find the value of n. So steps are like this. Okay, so here topmost point. Okay, so the ball is rolling here, so you can say here n number of steps are here. So if I take here, the ball is rolling from topmost step here in this way, say some velocity u. Now it is falling horizontally, it has to go horizontal, but because of gravity what happens, because of gravity it rolls and hits, say for example on the nth step. Okay, so you see the diagram I'm drawing, so nth step it falls over here. See, each width is here b, so n times means what here, nth step means how much horizontal distance b it has traveled. So total will be is equal to here n into b, 1 2 3 4 if you name like that. And similarly if you see the vertical height also, so draw the horizontal distance as nb. Now vertical also how much, h, how much will be, that is n into h. Now the x is equal to n into b, and the value of vertical height will be total n into h. Okay, you see every step n means, right? Yeah. Now so time taken, like in freely falling body you have seen already, isn't it? What you have seen, time taken is t is equal to root 2h by z. So and this nb will be the horizontal distance, isn't it? So each step has height h means, so what will you get here, So the total particular time taken to reach from topmost point to, okay, nothing but to trace this time, how much? Root 2h by g. Substitute over there now. So t will be is equal root 2 into h, means n into h, divided by g. Now therefore the x is equal to r is equal to n into b, which is equal to u into root of t value how much here? Root of 2 into n into h by g. Substitute there. 2 into n into h by g. So if you simplify and squaring on both sides, you will get n square b square is equal to u square into 2nh by g, and we want to find the value of u here. So u square will be one time n got cancelled, so u square is equal to g into b square by 2h, isn't it? G into b square by 2h, and from there we will get the value of u is equal to root of, okay, g by 2h into b. Clear? So this is how you have to find the velocity with which you have to throw horizontally, so that it lands at the edge of nth step. Clear? Yeah. Yeah, students, see, we are having a relief aeroplane is flying, okay, at constant speed of 600 km per hour above the ground, okay, towards a point. So this I am drawing aeroplane now here. So going to what speed? 600 km per hour. And height, how much it is? How much height given here? You can see the diagram. So 60 meters. U is 600 km per hour. Okay, so there is a person, so at a particular distance, okay, and when the aeroplane is released here, okay, at what angle of sight with the vertical should the point release, okay, the kit will hit the person. So when it's released, no, it will not travel directly simply down, so it try to travel along with the horizontal, isn't it? And then it will hit the ground. Now you see, so when I consider the body, that initial point to final point, that is line of sight, okay, so we have to find out the angle made by the line of sight with the vertical, see, that is theta here, okay. So now, so when you consider that value, ball immediately will not fall down, you see the diagram. So travel certain distance along with, then it will what? Because of gravity falling to the person, and the distance, okay, is nothing but here range, the how much distance it is traveling. Fine. Now, so that particular height h, and that value of height h is given to us, and time formula we know root 2h by g. So in that particular time t is equal to root 2h by g, the ball will or the drop kit will be hitting. So h value substitute here, that is 1960 divided by g value how much beta? 9.8. So if you cancel decimal into 10 by 10, you can multiply, decimal get cancelled. This is 2 times, so 20 into 2, root 400, that value is equal to 20 seconds. Now in that 20 seconds, r value will be how much now? U into t, that r, that is 600 km per hour. You can also convert into meter per second here, no issue. Okay, 5 by 18 into t will be 20 seconds. So if you simplify, this will be how many times goes here? So you can do the calculation here, no? 600 6 3, isn't it? So that is 20 into 100, 20,000 into 5. Okay, so 10,000 by 5 by 3, that becomes 10 by 3 kilometers, or you can keep in meters also, no issue. So now we want to find theta, right? So from this triangle, tan theta how much now? Tan theta is opposite side by adjacent side, r by, okay, so r by opposite by adjacent, r by h. So r is known to you, so tan theta is equal to, so 10,000 divided by, okay, so that 3 by h, again it will come in into, so that becomes 1960. Simplify, theta becomes tan inverse. How much become theta? Tan inverse. Okay, right, like that you can find out. Yeah, see here students, one point here, 4 objects are projected like this, Okay, the velocity on reaching the ground is independent of direction of throw here. Okay, so 1 2 3 any direction doesn't matter. So the velocity on reaching ground will be always v is equal root of u square plus 2gh. Keep in mind this one. So provided the vertical height is same, the velocity of projection is always remain the same. Okay, keep in mind height is important, same height. Yeah. Next problem you see, students, from the top of a 11-meter height tower a stone is projected, okay, with a speed of 10 meter per second, so at an angle of 37 degrees, okay, as shown. So find the speed of after 2 seconds, time of flight, range and maximum height above ground, speed just before hitting the ground. Okay, now see, so when first of all, when it is going from the point to here, ground point, so total, okay, say A, this is B, this is C. Okay, so for time of flight you can take off here as 2 from A to B, you can simply take 2u sin theta by g. So 2 into u sin theta, u is 10, sin 37 is 3 by 5 by 10. So your 10 get cancelled, 6 by 5. That value will be how much? 6 by 5 means that is 1.2 seconds. Okay, so now again from B to C, so you have to find out. So now from range above A to B, this value is 1.2 seconds. Okay, now from there after velocity, if you find here, is asking after 2 seconds, that means it will be below B somewhere else. So V, I resolved Vx Vy. Now Vx value how much beta? Remains same in x direction, 10 meter per second. Now Vy will be how much? U plus At. U means how much here? Uy plus A means here G into T. So if I take here vertically up as positive, now this becomes U 10 sin theta plus A is here minus Y because downward, so into 2. So V becomes now 10 into 3 by 5 minus 20. That is 6 minus 20 is minus 14. Here minus 14 means here it is vertically downwards here. So Vy is equal to 14 into, I can write, minus j cap. Right? So V bar is Vx I cap plus Vy j cap. So 10 into I cap plus 14 into minus j cap. If you want, you can also find its magnitude also. That is velocity after how many seconds? So that is 2 seconds. X component throughout the motion remain the same. Okay. So now next we have time of flight. Now you see, from point A to B to C. So in that one, so the distance traveled horizontal is range. In the same time, okay, the particle going from A to C, in the same time tracing horizontal distance, and the same time vertical displacement how much here? 11 meters, isn't it? So vertical velocity is u sin theta. That value how much here? So just now we have seen 10 into sin 37, that is 6j. So and vertical displacement is here how much? T is equal in same amount of time. Displacement is equal here minus 11 meters. Now minus 11 meters is equal to ut minus half gt square. So Uy substitute 6 here. Minus 11 is equal to 6. Okay, into t. Okay. How much t? You have to find out. Minus half into 10 into t square. And you can solve it now. So 60 minus 5t square. This implies 5t square minus 60. Okay, minus 11 is equal to 0. Yeah, here you can take ax square plus bx plus c. And t is equal to minus of minus 6 plus 6. Plus or minus root 6 square, 36 minus 4 into 5 into minus 11 by 2 into 5. That becomes 6 plus or minus root of 36 plus, this is 20 into 2, 220 divided by 10. That becomes 6 plus or minus root 256 divided by 10. And time cannot be negative here, you can take only positive value. Okay. So 6 root 256 means here 16. So 16 plus 6 is 22 divided by 10, which is equal to 2.2 seconds. So in this time, okay, it also tracing horizontal distance, isn't it? So now The maximum horizontal range is simply u into t. Already you know means u means x component. How much now range? That is 10 cos 37. So u cos theta, ux into t, 10 into cos 37, okay, into t. So ux already we got, isn't it? Sorry, here you see I wrote wrong here. U cos 30, 10 into cos 37 you have to do here, okay? So rectify the problem here, beta. And next to I am going for maximum height. So that value will be above the ground 11 meters plus that h is u square by 2z. So uy square by 2z plus 11 meters. Ui just now we have seen 6. 36 divided by 2 into 10 plus 11. That is 8 by 10. 18 by 10. 1.8 plus 11, which is equal to 12.8 meters. Okay. So this is what maximum height attained by the particle. Now just speed before hitting the ground. You can write direct formula now independent of direction of throw. No? So root of u square plus 2gh. You know u, that is 10 square. Okay. So plus, so 2 into g value is 10 into h value is 11 meters, and simplify, that will be the answer for this question. Okay. Yeah. So therefore that is root 320 meter per second. Yeah. Thank you. Yeah, students, okay, this is what entire horizontal projectile motion. Okay, so please do subscribe and like and share my channel. Yeah, thank you all.